So if we know that the period is the span of x's that we need to complete one full cycle, and we know that the amplitude is the highest y value minus the lowest y value, take that difference and divide it by 2, then we should be able to calculate the period and amplitude if they give us the graph. And this graph we've seen before. This is definitely periodic function. One full cycle, one block, or you could think of it this way, one full cycle, one block. And we could measure it from peak to peak. We could measure it from base to base. I'm going to start measuring at 0 because that's just easier for me. So if this is one full cycle, it isn't quite going from 0 to 6. It's actually going from 0 to 6.3. And if we went in this direction, it would go from 0 to negative 6.3 for one full cycle. This second block should be from 6.3 to about 12.6, so that it is still a span of 6.3 along the x-axis. So for y equals f of t, because they called it f of t here, the period is about 6.3. The amplitude, the highest y value is 3, the lowest y value is 0. Divide that by 2, and we should get 1.5 or 1.5. Now, if we consider this being the center line, it's sometimes called the midline, it's sometimes called the axis of the wave. The graph does go about 1.5 spaces above that center line and 1.5 spaces below that center line. On the next one, well, they told us this is y equals the sine of x. And we're going to get very familiar with this graph in a couple of weeks. So going across the x-axis, we could go peak to peak, bottom to bottom. I'm going to choose to go starting at 0 again. So the graph goes up and it comes back to 0. But that does not mean that this has a period that's pi units long. Because if it did, then this would be one full cycle, and this going back up again would be another cycle. But this starts at 0, goes up, down, passes through 0, goes down, and then comes back up again and is ready to start over. So from 0 to 2 pi, that is our period. We could have counted here, going from negative pi down through 0, up, and back down to 0, and ready to start this kind of cycle over again. Well, from negative pi to positive pi, that would still be a span of 2 pi. For its amplitude, well, the highest y value is 1, minus the lowest y value is negative 1, divided by 2. That says the amplitude is 1. Well, this one already comes with a center line, or with a midline, or with the axis of the wave. And that's definitely going one space above that axis, one space below that axis. Amplitude is indeed 1. The third graph is a little different. They didn't give us an identity, so I'm going to just call it y equals f of x. For the period, Well, it's hard to tell because it's got all these vertical asymptotes happening. So the vertical asymptote isn't at -2 here, because if it did go up and hit this, and vertical asymptotes don't cross the graph. It looks like it's at maybe -1.5. So I'm going to call the vertical asymptote there at -1.5. And then can't use x equals 2 for the vertical asymptote because it would definitely hit the graph. I'm going to say from -1.5 to +1.5 on the x-axis. So -1.5 to +1.5. Well, that should be a period of 3. We could also count, all right, the little twisty at 0, does another little twist here at 3. That would give it a period of 3. Or we could have counted here, does a little twist at 3, next little twist comes along at 6. All indications are the period for this function along the x-axis is 3 units. Amplitude. Well, that says the maximum y value minus the minimum y value divided by 2. This doesn't have a maximum y value or a minimum y value. We could say from infinity minus -infinity divided by 2. So we'd have 2 times infinity divided by 2, which is still infinity. That's not a number. So we're going to say no amplitude on this and let it go. We should also investigate how various transformations to the graph affect the period and the amplitude. So if we let y equals f of t minus 2, how does that transform this function? Well, it looks like it should move it, since it's inside function. You could pretend these are the x's if you want. It looks like it should move it to the left, but we know that the x's do everything backwards, so it's actually going to move to the right 2 spaces, which means where the graph is at -2 is actually going to move over to 0. And where the graph is at 0, that's actually going to move over to 2. And where the graph is at 2, that's going to move over to 4. And where the graph is at 4, that's going to move over, well, the graph at 4 is about here. And that's going to move over to 6. Yeah. This is hard to do. And then where the graph is at 6.3, that's going to go over to about 8.3. Where the graph is at 8 is actually going to slide over to 10. Where the graph really is at 10 is going to slide over to 12. Where the graph is at 12.6, that's going to slide over to about 14.6. So I'm going to try to connect the appropriate dots here. To move it over 2 spaces to the right. It looks like I kind of missed there. Sorry about that. What I was most interested in, what is the period after we've moved it over by 2 spaces? Well, it's going from 2 to 8 and a little bit more. Looks like the period is still 6.3. How about the amplitude? Well, the highest y value and the lowest y value didn't change at all. So the amplitude is still 1.5 or 1.5. How about if we try a different transformation? Suppose we try y equals f of t and then minus 2, which means it's vertically going to drop 2. It's going to go down 2. So in the original graph, where x used to peak at 3 here, x is now going to peak only at 1. At 0, the y value used to be 0. Sorry, the f of t value used to be 0. But now it's down to negative 2. And where it used to peak at 3, that's down now to only 1. And likewise at 6.3, that's going to be down here at negative 2 instead of at 0. When the t values or the input values are about 9.1 or so, sorry, about 9.4, the used to peak at 3, it's going to be peaking at 1. Where it used to bottom out at 0, here at 12.6, it's going to bottom out at negative 2. So our new transformed graph is looking like this. How about its period? What span of x's does it take? Well, it didn't move left or right. It just moved up and down. It's still looking like it's taking about 6.3 to fill one complete cycle. And the amplitude. Whoops. So it's going from a maximum value of y equals 1 minus a minimum value of y equals negative 2 divided by 2. Well, that's still 3 divided by 2. Amplitude is still 1.5. So it looks like the translations, the slides, if we move the graph left or right, if we move the graph up or down, it's not affecting the period or affecting the amplitude. Let's try some different transformations on the second function here, y equals the sine of x. Suppose we do y equals 2 times the sine of x. And this is our function, our f of x function. If this had just been 2 times f of x, we would know that this is going to be a vertical stretch. The graph is going to go twice as high and twice as low. So instead of bottoming out at negative 1 here, it's going to bottom out at negative 2. Now here the y value was 0. 2 times 0 is still 0. Here the y value was 1. We double that y value, it's at 2. 2 times 0 is still 0. Bottoming out here at -2 instead of -1. 2 times 0 is still 0. Instead of peaking at 1, it's going to peak at 2. 2 times 0 is still 0. And so on. I'm going to give it a vertical stretch of 2. And I'm going to try to draw it without it looking too terrible. Trying to keep some kind of curve in it here, instead of just drawing zigzags. So there's the graph. It's period. How many x values across do we have to go before we get one complete cycle? Well, if we start here at 0, we go up, down, go down negative, come back up again, get ready to start over. Looks like the period is still 2 pi. How about the amplitude, which I'm going to start abbreviating as amp? Well, that's going to be the maximum y value minus the minimum y value divided by 2. So that would be 4 divided by 2. Oh, the amplitude changed. When we doubled all the y values, we doubled the amplitude. This is going 2 spaces above the center line now, 2 spaces below the center line. But the period remained the same. One more. Suppose we try y equals the sine of 2x. Now this time the 2 is in with the x, which means everything is going to be backwards. Instead of getting twice as wide, it's going to be 1/2 as wide. Because the x's only have to be half as big in order to achieve the same height. So if we put a 0 in, 2 times 0 is still 0, so the sine value is going to stay right there. Now I split in between 0 and pi, there's half a pi. So the original function reached its height at half a pi. Well, now it's going to reach that same height in half the time. It's going to reach that maximum height by the time it hits pi over 4. Originally, we came back down again and hit 0 when the x value was pi. Well, it's going to do that now in half the time. It's going to hit 0 by the time we get to half a pi. It's going to bottom out. Now before, it bottomed out right here. Bottomed out at 3 pi over 2, 1.5 pi's. Well, now it's going to bottom out at 3 pi over 4. It used to take us out to 2 pi. Well, now, because we're doubling all the x's, we're going to get to this point again in half the time. We're going to get there by here. So our graph is going to be looking like this. One complete cycle by the time it hits pi. And then another complete cycle by the time it hits 2 pi. It only has to, it's going to be working twice as fast here. And so on. So for this function, the period is no longer 2 pi. We got one complete cycle in by the time we hit just 1 pi. So putting in this factor of 2, because the x's do everything backwards, the new period is going to be only half as big. We're only going to need 1 pi in order to get one full cycle. Its amplitude? Well, we didn't do anything to the y's. They're still going to go as high as 1. They're still going to go as low as -1. We divide that difference by 2, and the amplitude is the original 1. So applying the vertical stretches, the dilations, if we multiply 2 times the y, it does not affect the period, but it does affect the amplitude. If we do stretches and shrinks on the x's, it affects the period, but it does not affect the amplitude. For this last one, vertical stretches would just make it grow faster. It is not going to change the amplitude because it doesn't have an amplitude. We could shrink the period. We could slide it back and forth. We are not going to on this graph, which is actually the graph of y equals the tangent of x. Instead, we're going to ask you to go practice the first U try and come back and check out your answer.